So I'm going to be telling you about our first year physics courses and how we've been using technology to help cope with our ever-increasing student numbers. So in this talk, I'll just briefly tell you about UNSW, look at some of the questions with using technology. I'll give you the background of our big first year physics courses, Physics 1A and Physics 1 to problem solving workshops. I'll briefly tell you about our labs, because I think probably in maths you don't have labs, so maybe that's a bit less relevant. And then I'll tell you about the web stream lectures that we've developed for our courses, which let students use to take the lectures from home instead of face-to-face if they want to. And then finally assess and then look at how we cater for our physics majors, large 50 physics lost, and they're special to us because we want them to go on and do honours with us. Okay, so I started at UNSW in 2020 as physics director. I'm in charge of running all of our first year physics courses. UNSW's just introduced education-focused roles, so I'm now an education-focused academic, which means that I'm not expected to do much research. Most of my time is spent teaching and administrating courses. UNSW is one of the top 8 which varies from field to field, and the engineering faculty has a really good reputation at UNSW, so it's one of the top 2. So we have an awful lot of engineering students studying first year physics, so it's predominantly a service. The number of physics majors is quite small, so we've got about 50 doing third year physics and then only 10 doing honours year level physics. And in the past 7 years, our School of Physics has increased its F-schools, which is effective full-time student load, so basically number of students in courses by 100%. So we've had to utilise technology to cope with that. And some of those increases came from entirely online courses, but I won't be telling you too much about those today. I'll be concentrating on the Physics 1A and Physics 1B. So with technology, I think we need to consider how much do we want to do. In the School of Physics, we've got some entirely online courses. So there's a couple of examples there. One of those is the teacher's course. So developed a course to teach high school science teachers physics, because in Australia we don't have enough physics teachers. We've got lots of teachers teaching physics classes without physics qualifications. So this is an online graduate certificate to help train up the physics teachers. With Physics 1A and Physics 1B, there are really big courses. Everybody in those courses has at least 3 contact hours a week, so they have at least a 2-hour lab and a 1-hour problem-solving workshop. And then some of them choose to do 3 hours lectures face-to-face, and some of them choose to do the lectures online instead. And then we've got another Fundamentals of Physics course, which is much more traditionally taught. So all the students in this course have 6 contact hours a week, 3 hours of lectures, 2 hours of labs, and a 1-hour tutorial. Okay, so Physics 1A is an introductory calculus-based course. So it covers mechanics, thermal physics, waves and oscillations. Every student who's doing Physics 1A is also doing our introductory maths course, so Maths 1A as well. And the majority of the students in this course are engineers. The enrollments have been gradually increasing, so you can see the increases here. And our difficulty is that we have to timetable it before we know exactly how many students are going to enroll. And every year engineering is telling us, oh, we're going to have more students next year. So you can see that's not like always the case, but it keeps us on our toes. We have to be prepared for more students than actually end up enrolling. And we actually offer the course at a few different levels. So 1121's got the easiest assessment, 1131 has slightly harder assessment, and 1141 is a separate course for the physics majors to give them an opportunity to get to know each other. So their labs are a little bit different. We run the Physics 1A course twice a year. Next year we're running it 3 times a year. This is the number of students who do it in semester, the number of people who do it in semester 2. The semester 2 varies based on how many pass the first semester as well as how many enrollments we get. So I think this year in semester 2 we've got less enrollments because some of the things that we did to change our assessment actually work and more students pass. I'll show you about that. Okay, so in Physics 1A, they have 3 hours of lectures each week, which they can choose to take online if they want to, a 1-hour problem-solving workshop and 2 hours of lab. All our lectures take place in this lecture theatre here, which is the Keith Burrows Lecture Theatre, and our problem is that we're not allowed to over-enroll, we're not allowed to have it stairs, so it's kind of quantized, and 4 times 440 is very close to the number of enrollments that we have. So we always think that we're going to have to put on an extra screen, which is why we looked at creating the web stream for the lectures as well, because that would take the overflow, but students aren't forced into that. Everybody who's enrolled in that has chosen to enroll in that. So Physics 1B runs in a similar way to Physics 1A, but it covers different topics, electromagnetism, optics, and modern physics. So I'm going to tell you what went wrong as well as what went right. So when it started, we had really big tutorials. We had really big tutorials because physics has just with the number of academic staff. Remember to having tutorials in lecture theatres with over 100 people. And in these tutorials, it was just a person up the front writing the solutions to the problems on the board. We wanted the students to try tutorial problems before they came to the tutorial, but most of them didn't. So they were basically just copying down what was written on the board. So to me this seemed a bit silly because they could just watch this from the video. So I created videos showing them how to solve all the problems. The other problem was that in the tutorials, the person up the front didn't have time to solve all the problems. So do you cater for the weaker students who haven't tried anything and just problems, or do you cater for the more engaged students who want to do the harder problems, but then lose everybody else along the way? So having these videos just on YouTube, I just made them with a tablet voiceover as I did the working, went down well with the students. This was really popular. So when we students about the videos, if they found it useful or not used, the majority of them said it was useful. This was a few weeks before their exam, so the ones who'd not used, they'd not used it because apparently they didn't know about the videos, even though they'd had lots of announcements about it. But in the survey they said, I hadn't heard about this, I'm going to go use them now. And it looked like they did because we did have a really big spike in video use just before the exam. You know, as kids going into the exam going, I can't get your voice out of my head, I hope it helps. But I'm not certain how much it does help, because seeing somebody solve a problem is different to you solving the problem. It's probably a safety blanket for the students than actually necessarily teaching them. If they tried the problems and then watched the videos, I think that's helpful, but some of them were just watching the videos without trying the problems themselves. And it had the unintended consequence that since the students had all the videos online, they decided not to come to the problem-solving workshop. So this is what our problem-solving workshops look like. And most of the students said, well, a lot of the students said that they're not used or were not useful. And these were things on their timetable, so they definitely knew that these classes were on. So it's definitely not worth running tutorials with somebody up the front working through problems. So we took the opportunity to look into, well, what would work better. And research has shown that students learn better if there's lots of active learning. We need to address student steps and get them to face up to these and recognize them and see what's going on. So we decided to transform our classes from tutorials into problem-solving workshops. So in problem-solving workshops, the students get given a worksheet when they arrive. we've been changing from year to year if we give it to the students in advance or we give it to them when they get there. Initially, we were giving it to them when they got there so that everybody was starting at the same place. But feedback from some students was like that they'd like to come prepared. So we now make the worksheets available through our learning management system before the students come. So the team students can work through the worksheet before they come, and then they can act as peer tutors. So we can get some extra after class as well as the ones that we pay to be there. So the other thing we do in our problem-solving workshops is practice exams. So these aren't for marks, but I figured since we were weighting our examinations so heavily, it's only fair to give the students a chance to practice answering questions under exam condition and get feedback over the semester about how they are going with answering these questions. So initially we had some problems with running our problem-solving workshops in this format, because initially we only had these large lecture theatres. We ended up seating them every 2 rows so that the tutors could walk around the lecture theatre, but still it wasn't really the best environment for this type of teaching. So we were lucky in 2015, we got the opportunity to build a new lab. So we designed this new lab. I made sure that there was room to hold the problem-solving workshop and the labs in the same space. So this is a large flat floor space where it's easy for the tutors and the TAs to walk around and help all the students. And the students sit around these desks in groups of 6. It's a little bit crowded. We had to do that in order to be able to fit the 1,600 students in this space for 2 hours of lab and a 1-hour problem-solving workshop each week. But it's worked a lot better with the large flat floor space than it did in the lecture theatre. Okay, so the logistics, we have up to 100 people in the class, and with those people we have a PhD student or an academic member of staff. We also have a couple of TAs. So this year we've been using second-year students. We just choose the best ones, and they're very familiar with the content and the problems students come across in their understanding. So for that, that's worked well. And we also encourage the students to work as peer tutors. So being in Australia, we have this koala tutor program going, where if a student comes prepared to class with their worksheet all done, then the TAs check it off and give them a koala, and they walk around as a tutor to other students. And if they do this 3 times a semester, they get a caramello koala. But we also keep a record of them because we'll give them preference next year to be one of these second-year TAs. And these second-year TAs get paid quite a lot. It's like normal demonstrator rates, which for us is $50 an hour. That's quite a big motivation to get them to work as peer tutors. So I've just got the one slide on labs because I wasn't too sure how that would be for you. One of the changes that we've made to labs is in getting the students to come to class prepared. So before each laboratory class, the students have a video that they need to watch. This is a screen grab of one of them, where we outline the theory behind the experiment and then set up the experiment as well. And they then have an online lab quiz that they need to do, and this is worth a quarter of their lab mark. So they are all doing the online quiz. And when we introduced this, there was a significant difference in how when they came to class. So, I mean, I think that would work in anything. You could do that for tutorials as well, have a video introducing them to the concepts and then some questions that they need to try before coming to class. And the other thing that we've done for our labs is our IT people developed a location lock sign-in system. So this just kept track of all our demonstrators and TAs because there's a lot of them. Like there's altogether there'd be around about 60-ish. So when they arrive, they sign in out at the end, and it timestamps the signing in and signing out, and then that feeds directly into our pay system, which has made that part of the job run more smoothly. They've also added into this student mark. So the demonstrators have to mark the students during the lab, and now they just enter it into an iPad, and then that gets automatically uploaded into Moodle, our learning management system. Whereas when I started, they were writing it down on paper, and then you have to pay somebody to enter it into the computer, and then there's errors, and it's kind of a waste of somebody's time as well. Okay, so our other change has been introducing web stream lectures. So this was because we had to have an extra lecture stream of some form, either face-to-face, and we thought, let's take the opportunity to develop an online resource. So students can choose to enroll in the web stream lectures, but all students have access to the web stream lectures. So if a student misses a lecture, they can make use of the web stream lectures to catch up. So web stream lectures are not lecture recordings. We have lecture recordings as well, but all our lecture recordings record is whatever's on the PowerPoint slide. And in physics, we like to do a whole lot of demonstrations, and we also, well, most of us prefer to do working on the board so that we're not getting ahead of students. So we'll tend to have one projector down, and then that board we show the students how to solve these problems. So for the web stream lectures, when the students here online, they've got a list of learning outcomes for each of the lectures. They've got the interactive lecture, which is the lecture itself, reference to the textbook section, so if they want extra practice questions, they know where to look. PowerPoint slides, because a lot of them are second language, so they download slides and write on them as they're going. They find that a bit easier. And then reference to the homework sets as well, which they've then got the video solutions to. So they know after doing this lecture, they can try those problems, and if they get stuck, they know where to go to get the solutions. So what the web stream lectures are short videos first with questions. So Moodle's our learning platform. Do you use Moodle? Yes. So Moodle, we've set these up as quizzes. So inside the quiz, there's a short video embedded, and then there's a question after it to make sure that they've understood what's just been in the video. So the videos we aim for around about 5 minutes long. So there's different things that we do in the videos. We've got the theories covered, which is either just done in a film studio with the formulas appearing in the background or as voiceover PowerPoint. We've got demonstrations, so this is an example of a demonstration. And then we've also got worked examples, which are just recorded on the tablet. So in physics, it's been shown that if you just show students a demonstration, they won't notice the important points, and they'll forget 2 minutes afterwards what happened. So to improve this, you can use what's called predict, observe, explain, where you get to predict what they're going to see before they actually see it, and this makes them focus on the important points when they are watching the demonstration. So we've tried to use that wherever possible through the web stream lectures. This is an example here. We're asking them which flags are going to fall first before we actually play the video of the flags falling. And if you're interested in seeing our web stream videos, they're all on the UNSW Physics YouTube channel. So as well as the lecture content, at the end there's a few questions for the students to practice. So here's an example of the type of question, and I've purposely put in an incorrect answer there. So if students try it and get the incorrect answer, it gives them how to do the question, and then they hit try again. If they get the incorrect answer again, it then brings up a video explaining how to solve that question. So that's great, but are they actually learning in the online setting? So we've used concept inventory tests with our students. Widely used in maths, but in physics they're quite widely used, where we give students a test before, at the start of the semester, before we teach them anything, and then we give them the same test at the end of semester, and we look at the learning gains between how they went on the original test and how they went on the after test. So the force concept inventory test is a very commonly used test to test mechanics, which is what's in the first half of the Physics 1A course. Last year, the mechanics and TCS at the thermal, which was the second topic in the course. So for semester 1, the normalized gains for all of the students was 27.6, which is actually pretty good considering how much. These are fairly high pre-test scores. Our students knew quite a lot coming in. The more they know coming in, the lower your normalized gains are, because your the post-test minus the pre-test divided by 100% the pre-test. So you can see the students who enrolled in the web stream did a little bit worse than the students who, than the average student. But if they completed more than 80% of the web stream, they did a whole lot better. So, I mean, I guess that's not really surprising. The students who interacted with the learning materials actually learned something and did better, whereas the students who didn't learn as much. So we didn't have enormous numbers completing 80% of the web stream, but we did have big numbers on each of the individual lectures. So each individual lecture would have 400 to 500 attempts at that one. It's because a lot of the students are using these lectures to catch up when they missed an individual lecture. So they weren't necessarily doing the entire stream. They were using it a bit piecemeal. So for the second topic, which was the thermal topic, they seem to get some benefit just from being enrolled in the web stream. I'm not quite sure why that was. And if they actually did 80% of the web stream, then they did even better. In second semester, we have lower gains. This, I think, is because in second semester, we've got a whole lot of repeat students taking the course. When you speak to the repeat students, unfortunately, their attitude seems to be that they just got unlucky in the exam last time. They really do know it all, and this time it'll be very different without putting the effort in, which unfortunately doesn't work so well for them. So in semester 2, I think this is dragged down by the repeat students, but you can see that the engaged students, which there wasn't that many who did all of them, did really well in this. So in terms of our exam results, the average exam mark was 50%, so those enrolled in the web stream slightly lower, but those who actually completed 80% of the web stream did a whole lot better, and we've got similar results for the thermal topic as well. So the problem, and if they do it, then they are learning a lot. But we do.
Sorry, can I just ask a quick question? In that second column, you've got number and then enrollments in brackets.
Oh yeah, okay, so with the concept inventory test, I got ethics approval to do it. So this number is the number of students who agreed to be part of the survey and completed the survey. This number in brackets is the number of enrollments in the course, so it kind of is not part of the course that we're looking at.
Sorry, interrupt.
Yeah, so I mean, we're taking steps to try and get them to engage more with the web stream. Fortnight, I'm now merging an email to the students who haven't completed 80% in the last fortnight saying, hey, late, you know you're falling behind in the web stream lectures, you really should do them. By this time you should be up to here. And then at various times through the semester I tell them about this and how useful it is for them to actually do them, to try and encourage them to do that. We've also been trying to improve our face-to-face lectures with technology. So we've been trying to more actively engage students, because all the studies show that interactive engagement is the best learning game. Making use of Google Forms in our lectures to get students to ask questions as they go. And so we also use this for predict, observe, explain questions during lectures. So we use Google Forms because there's some other things out there, but a lot of them have limits to the number of users that you can have answering the questions at any one time. And Google Forms lets you how many people want. So when you've got 440 people in a lecture, which you probably don't because they're not quite all there, but you can have large numbers of students answering these questions, and then you can show them what the class thinks and talk through why people thought this way and what the answer actually is. So in 2013, I tried doing a similar thing with clickers because we were worried at this point that not all our students had access to mobile devices. It seems that in the meantime, a lot of them have now got access to devices or computers that they can use. I had a class head of clickers, which I took to lectures, but I found that that wasn't really worth it because you spent so much time handing them out, collecting them. It was more a novelty to the students than actual learning taking place. So I think technology needs to be kind of seamless. And so with the Google Forms, it works much better for us because we also embed the Google Forms into our Moodle page. So often the students will have that open during the lecture so that they can see the lecture notes. So it's pretty easy for them to get onto these Google Forms. Okay, so this year, we made a big change to our assessment. Our problem was that before I took over as first year director, we had to get rid of our mid-semester exams just because with so many streams, we didn't get all our students in the same place at the same time during the semester. So, I mean, we could have given paper-based tests, but that is then a lot of marking, and we already had an enormous tutor bill from paying for everybody for the tutorials and for the demonstrators in the labs, and it takes a lot of time. So we just the decision was made that this just wasn't practical. The problem was that the students then weren't really getting good feedback on whether they could answer exam-style questions until the exam. So most of them had kind of a false sense of confidence going into the exam, which got shattered when they saw the exam paper, which isn't really good for anyone. So students are struggling with the final exam. It was, 2016 and 2017, it was particularly bad, this problem. So instead of having mid-semester tests, we did have online quizzes for the students to do at home. But our students tended to collaborate, especially the weaker students. They would get high marks on the online quizzes, but then not have any clue what they were doing in the final exam. So, and then we had the honest student that some of the rating and getting extra help, and it wasn't really very good for anybody. Initially, we had these online quizzes set at 28 course mark. We reduced that to 10% because of these problems here. And then in 2017, our assessment policy changed. So with a 10% quiz and the 20% for exams, that left 70% for the final exam, and that wasn't allowed anymore. We're now not allowed at UNSW to have exams worth more than 60%. So we had to do something. So what we now have is 2 invigilated online tests, each worth 10%. We have 10% for at-home quizzes, but we've changed those. So I'll talk you through how we've changed these. And then 20% for lab and 10% final exam. So just to show you the problem, this was from 2017, before we had new assessment. You can see there's a lot of students here who are doing really well on the quizzes, but really, really badly on the final exam. So these at-home quizzes really weren't working very well. So looking at research, it shows this paper is not based on physics, it's from educational psychology, and they looked at maths and other things as well. And they looked at what makes students actually do well in exams. And it shows that practice testing and distributed practice works best. So practice testing is when the student practices taking a test at home before the exam so that they know how they're going to perform under exam conditions. And distributed practice is getting the students to practice answering questions over the semester and not just cramming just before the exam. And so I thought it would be nice to align the assessment with works in terms of learning. So make it in the student's interest to not cheat on the online quizzes. So in order to make the students not cheat, I created a large bank of questions. So we have 5 3-part questions based on each of the 36 lectures. So writing that many questions took quite some time. In order to write these, I started out by writing down what our learning outcomes were for each lecture, which has already been done for the web stream lectures, but not for all the lectures in the 1B course as well. And then over the semester, the students get fortnightly quizzes where they're randomly assigned questions pulled from these banks. They can try those quizzes as many times as they want, and their highest mark counts. So we're trying to encourage them to keep going till they know how to solve this type of problem. And then to ensure that it's actually them who's doing it, twice during the semester they come into the lab and do test questions pulled from the same bank under exam conditions. So there was also an unintended benefit of this. So because we were writing out all the lecture learning outcomes, I've now put this onto a Google Docs thing which all the lecturers have access to, and everybody annotates it with demonstrations and what works well, and it tends to keep our lecturers more parallel, which is good when we've got the multiple streams. So initially, Moodle didn't have the capability to do this, at least in our instance. So I ran a project where we looked for what's the best way to answer these questions in Moodle. Our university has Maple TA, which can answer these questions, but it doesn't tie well into Moodle, so then you've got lots of transferring marks between different databases. So we found that Stack, which is an open source plugin for Moodle, which uses computer algebra system, can ask the types of questions that we need to ask. So Stack allows for algebraic answers, so you can get students to type equations, randomized variables, randomized strings are useful for, say, if you want to change the planet in a question. You can have one student get a question about Mars and another about Jupiter, and they need to use their specific values. It also lets us have multi-part linked questions in the bank, which we couldn't have before. So before we couldn't have 3-part questions and then assign all those 3 parts like connected to the same student, which was actually a big problem for us. And yeah, one of the really good things is it allows for carry on marking. So because they're 3-part questions, if the student gets part 1 right and then uses part 1 to calculate part 2, but they perform that calculation correctly even though part 1 was incorrect, they get the marks for part 2. So they're not being penalised twice for one mistake. So I've just got a couple of slides showing you a couple of what our questions look like. So there's 180 of these for 1A and 180 for 1B. Oops. So we've got, this is just one where they do a calculation and they need to enter the numbers. So yeah, just a block of an inclined plane. If they make a mistake, it brings feedback up for them so that they can learn. So for the at-home quizzes, if they make a mistake, they get the feedback, they get a 33% penalty, and they can try again. With the invigilated quizzes, they don't get the feedback. They can see what their mark is, but they, yeah, because it's meant to be a summative assessment, we don't want to give them the feedback during the summative assessment. And here's another one which requires an algebraic answer to answer this one. Yeah, so then to actually run this, we run this test in our lab. So we have something installed called a safe exam browser, which locks down the browser and doesn't let them open additional browsers and things. So they can't look on other pages to look up, well, what was the answer meant to be. We give them 40 minutes and we assign them randomly 4 3-part questions. So this was really the only way I could think of doing it with this many students, because we can't have them all in the lab at the same time. So I thought giving them more equal opportunity to practice the questions beforehand made it as fair as I could do. For the first time we ran this, we weren't too sure about the different difficulty levels of the questions. So some of the students complained that their friends got all the easy questions and they got all the hard ones. Never actually the other way around. But so this semester, what I've done is categorize them into like easy, hard, etc., based on how the students performed in that question last semester. But I didn't have that information before we gave it to them, because I find it quite hard to work out how difficult a question is. Okay, so results. Yeah, these questions are hard questions, so I purposely made them hard questions to force the students to learn so that they didn't get a false sense of security, because they can practice it as much as they want at home before they come. So for Physics 1A, which is a lower version of the course, the average mark was 5.68 out of 10, and then for Higher Physics 1A, which is the higher version, they got 6.48 out of 10. This semester, those marks are up a little bit, because the first time we ran it, it was programmed to only mark them correct if they had the correct number of significant figures, and we've gotten rid of that because, I mean, that's not really ideal. If they know how to do the physics, they should be getting the marks. So there's just a few questions now that they need to answer with correct significant figures, and they're told about that. In test 2, they did a little bit worse, which puzzled me for a while, and then I spoke to the engineers, and apparently in week 13 of the semester they had a really big engineering project to do, so they didn't put too much time into studying for the physics test. But the really nice result was correlating the quiz marks, so this is combining the 2 invigilated quiz marks with the final exam mark. We don't have the students now who are doing really well in the quiz and then crashing out in the final exam. We've got much better correlation between how they're actually going in the quiz and how they're going in the final exam. So I think we're now giving them feedback about how they're actually going in physics. And the other nice thing was that because we forced them to answer so many questions over the semester, they did much better on the final exam. So the lecturers thought that the final exam was a similar difficulty level to the previous year, but the exam mark was 12% higher for the weaker students and 6.4% higher in this slightly harder course, which we were all very happy about because that led to greater pass rate, which I think is why we have lower enrollments in Physics 1A in semester 2 this year. So with this quiz bank, there was some technical problems along the way. I think there always is when you introduce something big and new like this. So all of those questions had little issues with them. So for this semester, we found it works really well to employ a TA to monitor the discussion forum, so the students have somewhere where they know to post. And this TA is really excellent. He's traveling around the world and funding his travels by answering these posts, and he knows how to program out and stack so he can fix the questions if there's any problems. In the first semester when we were running it, there was a stack update, which broke all the stack questions for a few days, which was quite stressful, lots of student emails, but eventually they got it fixed, and luckily it wasn't in one of those invigilated quiz marks. We've got a workaround for that now. We've just duplicated all the questions, so that's okay. And then there was a security update once during the in-class quiz too. So there was one morning in the class where they couldn't start it, but we shut down the firewall and then they could get in, so that just delayed us half an hour. It was okay. So I think overall, there weren't too many difficulties with introducing these new quizzes. So a change that we're making this semester is that some people in our university have come up with a way to scan exam papers. So they put an individual QR code at the bottom of every page of the exam paper, and the students put their student on the front so we know which student has which QR code. And then this feeds the exam paper directly into the assignment tool in Moodle, and it allows for online marking, which is very useful for us because with the big cohorts, we try and have one person mark all of an individual question in the paper. So there's lots of passing papers around. We generally get PhD students to do this, and they tend to work at night time, and we don't want to be in at night having the lab open so that they can come to do it there. And we definitely don't let the PhD students take the papers out of the lab. So we're hoping that this is going to work well as well. And the big benefit for students is that it allows students to see their final exam paper, because in the past we haven't let the students see their final exam paper unless they come specifically ask for it, because with 1,600 students it really wouldn't be manageable. So this way they can see from and hopefully learn from their mistakes to improve their exam technique for next time. Okay, so the final problem we had was the small number of physics majors in the really big engineering cohort. And these guys are special to us. We want to get to know them and persuade them that physics is very cool so that they don't go and change over to being a maths major. So we set up a separate course for the physics majors. In first semester they have the lectures concurrent with all the other ones, so it didn't increase the work for the academic staff. But they have a separate lab and problem-solving workshop. So in those environments they do get to know each other. And then in second semester they do have separate lectures. So this was the class from semester 2. I lectured them for the first half, and at the end they asked for a class photo. So that's me and that's the student in the physics majors class. So the feedback from this has been very positive, and I think it does help us keep our physics majors and move after first year to maths or chemistry or somebody else. Okay, so conclusion. When use many advantages to staff and students. Yeah, I mean, I wouldn't recommend using technology for technology's sake. I don't think that works. I think you have to have something that you want to do and then work out, well, what technology will be able to do that for you. When introducing something new, things will go wrong, so have plans in place for how to cope when these things do go wrong. Yeah, with our invigilated class quizzes, it felt like last semester, the minute I walked out of the lab, stuff started to go wrong. So we made sure that there was lots of people trained up in what to do with the common mistakes. So for academics, there's a big upfront cost in time, etc., for preparing these resources. Those writing 183 part questions for twice for 2 courses took ages, and the web stream lectures took ages as well. But once they're there, and we can use them going forward. So it's a big upfront cost will pay us later. Okay, so thanks for listening to my talk.